As I said, today I want to talk about Cad Cell controls. Okay, it is the primary safety control everybody is going to be using when you get into the field. Okay, a couple different varieties, but they all work on the same principle. I want to talk about that real fast. The other thing that I want to talk about, I'm going to go over the troubleshooting question that I gave you, because again, that one was pretty important. And then I also want to talk about real quick the exam on Friday. Now, let me go over this before you guys have a whole bunch of questions. It's just going to be much easier with that respect. Okay, the exam on Friday is not designed to take as many points as possible from you guys. That's not why I give exams, okay? Quite frankly, I give exams more for you to know how much you learn and for me to have some sort of measurement on what has been accomplished. Okay, the exam opens on Friday at 12:01 a.m. In other words, for you night owls there, you could take it before or after you go to bed. Okay, you must be complete by 11:59 p.m. on Friday. In other words, I'm leaving this exam open for the entire 24-hour period. Okay, don't miss that window. Okay, you have 24 hours to take it. I think that's pretty fair. The attempt does have a time limit. Okay, now the time limit you're going to find is going to be excessive. It's going to be more than you need. Most of you guys take these exams in about 30 to 45 minutes. Still don't understand how you do it. But whatever you do, do not open the exam and walk away from it once you've opened it. Even if you close your browser window, that date and time you opened that attempt, okay, is recorded in the system. You close the browser window, go about your day, okay, you're going to come back and find that the attempt is timed out. Okay, so don't open the exam unless you're going to be able to sit there and take it. Okay, for those of you with children, don't open the exam and leave your iPad sitting around, okay? Because we've had a small issue with some of the kids around submitting exams accidentally. Please don't do that to yourself, okay? Now, again, you'll find the time is, I haven't looked at the exam yet. I still have to go review it, but I'll take care of that. But you'll find the time limit is more than fair. I'm going to remove any of the matching questions. You know those matching with the drop-down matching lists? I don't like the way they're graded. So it just isn't a fair grading on them, and I just prefer to pull them off. So I'm going to go do some checks on that exam in the first place. Now, I'm going to give everybody 2 attempts on this exam, and I'll tell you why in a second. I'm going to give you 2 attempts. The system will keep the grade of the best attempt. Now, I'm not naive enough to think that if I put a single attempt out there, that people aren't going to use books, notes, and whatever to pass it. It's just the way it is, okay? I know it is, and I'm not that awfully worried about it. The reason I am giving you 2 attempts is that I would ask that you take the first attempt as closed book. Okay, go through it once as a closed book. Let's find out how much you actually know. This is more for yourself, because I think you guys did learn, based on what I've been seeing on posts and assignments, you guys have learned a tremendous amount this term, okay, in the last 3 weeks. Okay, so take the first attempt as more of a check for yourself. Then, as far as I'm concerned, you can take the second attempt using whatever available resources. Okay, so again, I'm giving you guys 2 attempts on this. Okay, I will keep the higher grade. Okay, now, having gone over that, does anybody have any questions?
No, sir.
Anybody else?
No, but I can't see your screen right now.
What are you seeing? What are you seeing?
Just black.
Okay, are you through internet, or are you dialed in?
Through the internet, I believe. I'll leave the call and try and pick it up again. Maybe that'll make
Yeah,
sense.
why don't you do that and then let me know if you're okay.
All right.
Okay. Any other feelings on any other questions on the exam on Friday?
Is this the final, or?
This is the final for the classroom portion of this course.
Okay.
And I want to be careful on how I'm wording that, okay? Because you guys still have a ton of shop work to do, so I don't want to say it's a final exam, but it's for the classroom material for this course.
Okay.
Does that answer your question?
Yes, sir, it does.
How many
Okay.
questions is it?
I knew someone was going to ask me that. I have not gone and looked at it. It's probably going to be around 80. And my guess is that you've seen all the questions before. And again, the reason I'm not going to give you an exact answer on the number of questions is I haven't removed those matching problems yet. I know there's some matching in there and I want to pull them. Because those matchings grade 100% correct or wrong. It doesn't grade each individual match by itself, and I don't think that's fair. Any other questions? Okay, that takes care of the exam. Mike, are you back with me?
Yes, I'm all set now.
Okay. One other thing, I did put several notes on assignments. I made some notes on people's assignments. Please, if you turn in an assignment and you don't see a grade, please go look at the note that I may have put on the assignment. If I don't see a file uploaded where there's supposed to be a file, or if I get a blank file, I'm going to put a note on it, and 9 out of 10 times it says, please send it to me via email. Okay, again, my purpose is I don't like giving zeros. Okay, I don't want to give anyone a 0. But please, I do need to be able to read the assignment. So if I put a note on it or something, it's just because I haven't been able to read it. Now, the other thing that I just really wanted to touch base on was I wanted to take a look at the troubleshooting question that I gave you on Friday. Okay? The troubleshooting was basically you pull up to a house on a nice, cool January evening. In other words, it's cold. The customer's called about no heat, and their house is very cold. You go through your standard introductions, prove who you are, because people like seeing IDs these days. Where are you going to start? What are you going to check first, second, and third, and why? Anybody want to tell us how you answered this question?
I actually answered it by going to the thermostat to see if the thermostat was set to heat or cool, and to make sure that temperature was high enough.
Okay.
That's where I started.
Okay, where did you go next?
From there, oh geez, I gotta pull up
Or
my...
where would you go next? You don't have to go back and look. Where would you go next?
From there, I checked to see if the furnace was turned off or not.
Yep, the service switch at the top and bottom of stairs. Okay, then where? Now you're in the basement or wherever the furnace is. Where would you go next?
Check the pilot light, if there is one.
Okay, does an oil furnace have a pilot light?
No.
No.
No. Anybody else? Eric's first and second points are really good. Okay, the thermostat should be the first place you go. That's perfect. Okay, that's what I was actually looking for. Then the service switches. We haven't talked a lot about them, but honestly, people with kids, 9 out of 10 times someone's turned that service switch off. Okay, especially if you have a built-out basement that's also used as a kid's playroom or something like that. That service switch gets turned off. Okay, and some people turn the light switch off at the top of the stairs that says oil burner shut off. Okay, the third place though, where would you go after you check the thermostat and the service switch? What's your next obvious thing to check?
The oil tank.
Thank you. Okay, people run out of oil constantly and don't know they run out of oil. Okay? So if you don't have oil in the tank, is there any chance whatsoever that heat's going to run?
No.
Nah. Okay, so, but guys, I wasn't really grading on the second and third points, but the first one I have said a number of times, always start at the thermostat. Okay, please, and realize, and a couple people gave me that pilot light. Oil furnaces don't have pilot lights. They're either on or off. So, but I was primarily looking at that thermostat. Okay, you got to start at the thermostat. It's the easiest place to start to while you're talking with your customer. Okay, and it's the easiest place to gain credibility with your customer. How bad would it look for you as a burner technician if you went through the entire hour diagnosis of that oil furnace, took it apart, put it back together, took it apart, was sitting down there in the basement with everything, the homeowners watching this whole thing, and then as a last checkpoint, you go turn the thermostat on and realize that the thermostat was turned off the entire time. How bad would that make you look as a service tech?
Why wouldn't you call me back?
Yeah. That wouldn't really be good. So part of this all has to do with our appearance as a service technician. You want to look like a professional. Get in the habit of doing things the same way every time. I do not go into a house, regardless of what I'm looking at, without, after I'm talking to the homeowner, like the introductions, what's wrong, sir, basically making sure the dispatcher got the call right, because they're famous for that too. But you don't go into a house without checking the thermostat. Okay, just don't do it. Okay, let's talk about what we need to talk about today, which I want to talk about primary controls. Okay, primary control is both an operating control and a safety. It has value equally as both an operating control and a safety. Okay, so keep that in mind. The primary control is used to regulate the burner sequence. That's the operating portion of it. Okay, it turns things on and off based on a call for heat. And as they get more complicated, it might turn your ignition off after flame's established. Why run the igniter if we don't have to? It might have an oil valve solenoid on it that actually allows a cleaner startup and shutdown. But primarily, it's that's its operating control side. It does the sequence of operation. Now, on the other end of it, we have a burner flame safety feature. The flame safety feature ensures that the flame establishes within a reasonable length of time. Usually that's 90 seconds. In the older controls, watch this. They've now come down to, in the newer controls, they come down as far as 30 seconds. From the point that that control thinks it's supposed to have flame, it has now come down to, could be only 30 seconds. We call that the trial period. So in one unit, in one little box, and I showed you the box on our call on Thursday, okay, we have our operating control, which is the sequencing, and we have our safety control. It senses the flame. If the burner doesn't ignite within the time frame after the thermostat calls for heat, or if the burner goes out for however long time, 90 seconds is the max, the burner motor is stopped and the control has to be manually reset. Okay? Whole idea is that we don't have an excess of oil building up in the combustion chamber. Okay, every time the oil burner starts and no flame, I'm spraying unused oil into that combustion chamber. If it's 90 seconds, I'm spraying 90 seconds of oil into that combustion chamber. It may not sound like a lot, but if it starts up after you've done this 5 or 6 times, it's going to be a big bang with lots of smoke. Okay, so we don't want unburned fuel building up. We have 2 types of flame safety controls. We have the stack switch or the stack relay. Folks, the only reason I still cover stack switch and stack relay in this course is it is on the oil burner licensing exams in both Massachusetts and Connecticut. And if you take the license for those, I don't think I have any Pennsylvania on this call, but it's on the licensing exam in both Connecticut and Massachusetts. They still talk about the stack switch. Okay, so just be very aware of this. You might come across them. You can no longer install them, and we replace them with the Cad Cell whenever we possibly can. Okay, so the stack switch is older style control. It looks like this. Okay, the stack switch, it's mounted on the furnace exhaust, the stack. Okay, this side here that I'm circling is outside of the stack. Okay, it's in the room air. Has a reset button on it. Has a little lever on it. Okay, and this part in the back here is what's in the flute pipe, and it's mounted by screws right there, and there's one down further as well. It has been in use for many years. I mean, this was the first automated control we had on oil furnaces. Okay, when they first started blowing up in New York City because of the unburned oil that was getting them, they decided to go this automated control, and it works. Okay, it has a piece of bimetal in here. Again, bimetal is metal that expands and contracts based on heat. Okay, it senses the heat in the flue pipe, and it expands, pushing a drive shaft in, basically pushes the drive shaft in. The shaft then closes the hot contacts, and I'm going to show this to you on a diagram afterwards. Okay, so all this is a set of contacts with a bimetal switch in here. Okay, if there's no ignition and consequently no heat, we have what's called a safety switch heater. Remember I talked about bypass when we were talking about circuits? Okay, if there's no ignition and no heat, there's a little heater in there that remains in the circuit, and it's not bypassed. This heater heats up and opens a safety switch based on the heat, and it shuts everything down. Okay? To start the cycle again, you must manually shut off the system, depress the reset button, and it starts all over again. Now, is the stack switch a very fast safety, or is it a slow safety in grand scheme of things? Is it slow or is it fast?
Slower.
It's slower. And it's designed to be slower because I have to have heat in the stack, in the output of the furnace, in the exhaust, before I can even sense that there's flame. It's a slower safety. Okay? Which is part of the reason it's going away. It's not accurate enough for the newer burners. And also, a lot of the newer equipment, we don't necessarily have such a high stack temperature. Think about it. Heat that's going up the chimney is wasted heat. It could be coming into the house and heating the house. So that's a wasted heat. Okay, so we keep our stack temperatures lower now. Okay, our other type of heat, our other type of safety, is the Cad Cell Relay. Okay, it's the Cad Cell primary control. Looks like that, or it could look like the black one that I'll show it to you again, but I showed you on the screen the other day. Okay, these are all different types. It's flat, it's mounted onto the burner assembly itself, usually on the right side of the burner where the wiring compartment is. And everything connects into this. Okay? The Cad Cell Relay, instead of using the stack relay, it's called a Cad Cell. The main component of this relay is the Cad Cell itself. Everything else is based on the Cad Cell. Okay, the Cad Cell is made from a chemical compound called cadmium sulfate. Okay, that's what the Cad Cell is made from. It's a substance that changes its resistance when it's exposed to light. Okay, so this is actually mounted inside the burner tube. Okay, and it's aimed down the burner tube towards the flame. So until there's flame, this is in the dark. Okay, it's made up, so it's a combination of the cadmium sulfide, a small ceramic disc, and a conductive grid and electrodes. Okay, you don't break these things apart. I really don't care what's inside of it, but I do need you to know what it's made out of. Okay, and again, it changes resistance when it's exposed to light. The Cad cell has to be positioned in the oil burner so it can sense the light that is being produced by the flame. It looks down the tube from the control side. It's usually mounted on the underside of the transformer, so that when the transformer's on the top of the flame or on the top of the igniters, that Cad cell looks down the tube towards the flame. The only light that Cad cell is supposed to be seeing is the light produced by the flame. When the oil burner's off, there's no light being generated. So the resistance of the Cad cell is very high. It's about 100,000 ohms, and it's very possible on your meters it could read OL. Okay, so if you take the resistance across a Cad cell when it's in the dark, your meter might read 100,000 ohms, okay, or close to it, or it's going to read OL. When the burner is firing and the Cad cell sees light, the resistance is going to drop down to under 1,000 ohms. Okay, so again, no light, very high resistance. When it sees light, it drops down to 100,000 ohms, or under 1,000 ohms. When the Cad cell, when you're testing it, this is exactly what you're testing. Cad cells go bad over time. They only last about 3-4 years. Okay, they do wear out, and you've got to be able to test them and make sure they're still good. It's a source of service calls. Okay, now what the Cad cell is doing, do you remember I talked about the bypass circuit again? You have a heater in here that's actually going to pop a safety switch open. Okay, that heater heats up as long as the Cad cell is in the dark. I have the Cad cell here, which is basically a variable resistor. Okay, and pardon my drawing of a variable resistor, but it's a resistor with an arrow through it. Okay, when that Cad cell drops its resistance, it's actually a lower resistance than that heater. So we won't pop the safety switch that's going to be heated up by that heater. So we have a situation, this is a use of a bypass circuit. Everyone was wondering why I was so insistent we talked about bypass circuit. This is why. The voltage is going to take the path of least resistance in this control. Okay? Cad cells have to be clean. So if we have a lot of soot in the furnace, you have that Cad cell eye. If I'm looking straight at the Cad cell and we have resistance, we have some grids in here. Okay, you can look at the eye and you'll be able to see that. If this is all sooted up to the point it can't see the flame anymore, or it's a very dim flame, the Cad cell isn't going to work. Okay, so we want to be able to see the eye of the Cad cell. Okay? And this is basically what it looks like. Okay, we have two electrodes that provide provide our wire, our connectivity. We have a conductive grid, and we have the cadmium sulfide. When I put a meter across the back part of this, the two pins that are coming out of it, if my Cad cell is in the dark, or if I have it covered with a piece of electrical tape, my meter is going to read OL, or it's going to read very close to 100,000 ohms. Okay, no current is going to pass through that. It's all going to go through the heater. Now, if I put this in the light, that number will change to a number under 1,000 ohms. Okay, and I'm going to tell you it comes pretty far under 1,000 ohms. Okay, so again, Cad cell in the light, low resistance. Cad cell in the dark, very high resistance. Okay, you have to remember that. That's a memorization thing. Got to remember this. Any questions on that?
No, sir.
Nope.
Okay. Okay, so when we look at an oil burner, Okay, sometimes you have the CAD cell mounted on the back of the burner here, almost directly under the transformer. Sometimes it's actually mounted on the bottom of the transformer looking down here. The whole purpose of the CAD cell position is that it has to be able to stare down this burner tube, and it has to be able to see the flame. Okay? The cell has to be protected from external light. When you have an oil furnace, anything that is here, okay, anything that this burner's in has to be completely dark. No external light. This area has to be sealed. There's gaskets around here. No external light. Everything around this has to be sealed. Okay? This CAD cell cannot be heated over 140 degrees. Okay, so again, this burner has to be throwing sufficient air down this tube to keep that CAD cell cool. Okay? Has to be away from metal so that, again, we can't have movement. We can't have shielding from the light. We can't have any, like, infrared radiation hitting this CAD cell. It has to be able to see the light but not be affected by the heat. Placement of this CAD cell is extremely important. Again, these things fall loose over time. There's a little bit of vibration in all oil equipment. Things get loose. With the furnace off, we take the two leads of off the CAD cell. Okay, and I'll show you where it's connected. Okay, we take the resistance. The ohm meter, okay, should take a reading way over 100,000 ohms. Okay, you don't have to worry about this step anymore. This was before we had auto ranging meters. Okay, you used to have a different scale. Your meter's all auto range now. Okay, but we wanted to set our meters for the 1K ohm scale. Okay, you don't have to worry about that step anymore. Okay, you place the meter leads on the two yellow wires. The meter should read a reading. Now, we jump out the T and the T terminals, and I'll show you where that is on that's basically where your thermostat connects into. The furnace should start up. After the furnace fires, the resistance should be low, somewhere between 600 to 1,000 ohms. Quite honestly, most often now it falls under that. But any place 600 to 1,000 ohms or lower, you're fine. That CAD cell is perfect. If the CAD cell is good, the CAD cell is good if all of this happens. If it doesn't happen, replace it. You can't fix a CAD cell. The CAD cell is preferred over the internal stack switch. It acts faster, has no mechanical moving parts, and is much more dependable. Okay? So CAD cell is what we're using. It senses light. As it senses light, the resistance drops. It's a stupid little $2.50 part that is the heart of the entire oil safety controls on every single furnace. Okay, I want to talk one more about it, but it's going to be on a separate PowerPoint. So just give me a second and I'll switch over. Any questions on what I've covered already?
No, sir.
Okay. Okay. This is the picture of the CAD cell that's actually mounted on the bottom of the oil furnace. Okay. Didn't want that. Okay. You see that this is my transformer. We have the springs of the transformer, and then we have the CAD cell positioned between the two springs of the transformer. This CAD cell, where it's mounted, actually slides in and out. This whole CAD cell assembly will slide out of this. You don't have to take any screws off or anything like that. It slides out of it. In some other furnaces, they're mounted in slightly different places. They might be mounted specifically into the control on what we call Riello burners. Okay, but you can replace this CAD cell by just buying the little lens by itself. Okay, you don't have to replace the entire assembly. When you look at the top of a primary control, you have two terminals, and this might be tough for you to see right now, but I'll show you a better picture. Okay, there's a T and a T terminal. That's where my thermostat connects. If I close the connection between T and T with just a wire, my furnace will start up. Okay, we also have an FF terminal. F and F, that's where my Cad cell connects into. That is always yellow wire. Okay, FF terminal will be yellow wire. That's what your Cad cell is shipped with. Okay, TT, I can jump out and I can bypass the thermostat. Just whatever you do, if you ever jump that out in the field, make sure you remove the jumpers when you're done with your service call, because you'll get called back later in the day when someone's house is near 100 degrees. Don't do that. Okay? And then FF is where my Cad cell is. Now, if I have a bad Cad cell, I cannot jump out FF. Okay? You cannot jump FF out. The safety is specifically designed to check and make sure that the Cad cell is showing high resistance before it will allow the system to start. It's to prevent someone from jumping out the safety. Can't do it. Okay? So again, it's a flame sensing device. Okay? We've already gone over this. Again, have to be able to see the tube, the presence of flame. Stops pumping oil into the combustion chambers. I've said it twice now. It's pretty important. Got to stop pumping oil into the combustion chamber if the flame goes out. Okay? Yellow wires, that's the key. Yellow wires. Okay? Trial for ignition is a term you're going to see quite a bit. Not going to read all these slides, but trial for ignition basically says, let's make sure we have flame. Let's make sure we keep flame. Let's make sure I'm burning all the oil that's going in there. We don't have a pilot light. If there's extra gas going in, okay, I don't have the luxury like I do on a gas furnace of having a pilot light that will burn the excess. Okay, I have to know that the oil is actually being used for something. This is a computer-controlled primary. Remember this is one I showed you the other day. Okay, all my connections are on the bottom of it. All of my my Cad cell connects in the bottom. The only terminals I have on the top of it are my thermostat connection. It's all computer-controlled. There is no reset button visible to the customer. Okay, why don't I want a reset button visible to the customer?
People love pressing buttons.
People like to press buttons. There's no reset button visible to the customer. There is a little blinking light over here that will tell people if it's seeing a flame or if it's been locked out due to a loss of flame. Now, how do you think you reset this?
Somewhere underneath.
There was someone else who said something in the background. What was that?
You have to hold a button for like 3 seconds or something?
Well, there is both are actually correct answers. Underneath, there is a button. Okay? It's not just 3 seconds. You actually have to hold it down for 90 seconds. But how do you think, who in here has had gas heat already? How do you reset a gas furnace? Oh, someone has had this already. How do you reset a gas furnace?
I think you have to hold the switch in for a certain amount of seconds, and then it'll light.
That's one type, but the other type is you turn the service switch off on the side of the furnace and you wait 90 seconds and you turn it back on. Believe it or not, some of these furnaces, these primary controls, actually will let you do your initial reset up to 3 times by just turning the power off and back on again. Anything past that, a service technician has to take this cover off, turn it upside down, and hold the reset button in on the bottom. I have no problem telling a customer to turn that power switch off and wait 90 seconds and turning it back on. I have no problem telling them. It's only going to let them do it 3 times. Okay, and these have a 30-second lockout, so my risk is very low. Would I ever tell a customer to take this off and turn it over and press that button?
No.
Oh, no.
No. Not to mention there's line voltage down here, which would be extremely dangerous. But it's usually not a good idea. If something's screwed down, you don't tell a customer how to deal with it. Not a good idea. Okay? The basic system, this is the Beckett Genesis control. Okay? It's compatible with all types of controls. Can be compatible with burner, can be compatible with power stealing 24-volt thermostats, in other words, thermostats without a common. Okay? But they're designed for oil burners with less than 20 gallons per hour. Okay, again, they do have a maximum size limit, and that's because of code. They cannot be used on oil burners that burn more than 20 gallons per hour. Now let's think about that. How many BTUs does a gallon of oil burn? Come on, folks. How many people?
140,000.
100 and, I thought it was 14,000. No,
It's 100. It has a range, so you're okay on that. But could it be between 130 and 140,000?
Yeah.
Yes.
Okay. So think about 20 gallons per hour. Where would you see an oil burner of that size?
Industrial.
Commercial or something.
It's going to be mainly industrial, where we're using oil heat to do a process. Could be in a very large office building. But I mean, an oil burner of that size, you're not going to want to stand next to it when it fires up. Okay, you're going to want to be across the room or preferably out of the room. Okay, because that is going to pulls a ton of air in, because we have to pull air in, and that is a specialized control system. Okay, has more than one safety, because even 30 seconds at 20 gallons per hour has a ton of unburned fuel that could drop into that combustion chamber. Okay, so again, these controls that we're talking about is under 20 gallons per hour. Okay, limited resets, okay, basically means recurring lockouts without a complete heat cycle. Puts a control into a restricted or hard lockout mode. Okay, it allows you to have a limited recycle. If a flame is established and then lost, the control will recycle until a cumulative time trial for ignition is exhausted. Okay, and then it goes into a hard lockout. Okay, so again, what do we mean by a complete heat cycle? What does a control see with a complete heat cycle?
Combustion.
It sees combustion.
Air.
Okay, but how does my control know that I've had a complete heating cycle?
Through the Cad Cell?
Well, remember those two terminals that I told you, TNT, that my thermostat connects into? So if I have a complete heat cycle, my thermostat calls for heat, right? Closes TNT, my burner runs, but then at the end of the heat cycle, my thermostat is going to open and it's going to shut off the burner. So basically my control knows that a complete heat cycle happens when TNT is no longer closed. I've had ignition, I've had flame, and I no longer have flame because TNT is open. Okay, recycle. Okay, since no one's going to ask me what recycle means, it basically means that it's going to try to ignite up to whatever my cumulative time trial is. So if my control is a 90-second control, okay, my ignition control is going to attempt to relight the oil until it reaches a total of 90 seconds. Okay, so it's going to try to recycle on its own. It's going to try to redo itself. It's going to try to bring that oil back on. Let's say there was a little bit of air in the line, which we'll talk about further as we move forward. But this control is going to try to reset itself a number of times until it reaches whatever my total time allowed is. Okay? The computerized control keeps track. Even if you turn power off, it still keeps track. It has a display on it, on some of them, okay, where you can actually you have a contractor tool, okay, where you can actually plug another control, something you carry with you as a contractor. You can actually plug it into the control that's on the top of the furnace, okay, and you get much more of a display than what the customer is going to get. It gives you some additional programming options, gives you troubleshooting options. It will actually tell you what the resistance is of the CAD cell in the system. So you don't have to take your meter out. You don't have to unscrew wires. It will give all of that for you on the contractor tool. So there's a lot of computerized stuff in this. It's Beckett's goal that eventually this control is going to be internet driven, okay? Where you'll be able to automatically get a notification as a contractor that someone's oil burner's having problems before they even know they're having problems. So the whole goal is to get to an advanced repair situation. The display has 5 main functional groups: current burner status, burner cycle history, pre-time change, post-time change, and service message customization. Okay, pre-time means how long is it going to keep the burner motor running before it allows oil in there. In other words, how long are we going to blow air through the system before we start the ignition sequence. The post-time means how long after the flame goes out are we going to blow air through the combustion chamber. Okay, burner cycle history just shows us the history of the lockouts, history of the call for heat, history of everything that has happened, usually within the last 7 days. It keeps that much history. So I can cycle back and I can see what the calls for heat were, how many times someone has been able to reset it, what's happened to it. Current burner status gives me all my information about, is it running, even though I should be able to see that, what the resistance of the CAD cell is, what the resistance and status of if there's a solenoid valve that's on the oil line, gives me all of that. Some of them are even giving pump pressures now. Okay, service message customization basically means what is displayed to the customer if it needs a service call, if it locks out. Do we put in the contractor's phone number right there? In other words, your system has a problem, call this number. Okay, so service message customization. What do we want the customer to see? All of this is programmable in these newer controls, but it still has the same basic functionality. Okay, it is an operating control and it is a safety. Okay, and again, the yellow wires on an oil furnace always lead to the CAD cell, unless somebody has changed wires out, and they really shouldn't. But the yellow wires lead to the CAD cells. Okay? Now, 15 to 20 seconds is some of our newer controls. That control I just saw you, 15 to 20 seconds. Okay? Is how long the burner will run without seeing light when there's supposed to be flame. Very, very fast. Okay, again, we've talked about this. Okay, if it becomes coated with soot, It won't see the light. It's going to shut down the burner. It's going to cause random lockouts. Should there ever be soot in a combustion chamber?
No.
Not really. You might have a little tiny bit on startup and shut down, but there really shouldn't be soot. If these burners are adjusted properly, they should be burning relatively clean. Excessive soot on a CAD cell. I know I have more problems than just having a block CAD cell. Okay, I could clean the CAD cell. The burner might run, but you better believe if I see soot on the CAD cell, I'm going to go investigate further because you're going to get a call back. What did I tell you is the most often improperly adjusted thing on an oil furnace? Technicians hate to adjust this because it's such a pain.
The nozzle system?
Basically the nozzle assembly, primarily those electrodes. Takes like 4 hands to adjust them, and you only have 2. Okay, those electrodes are the biggest issue with the oil burners. Okay, and if they're not adjusted properly, yeah, you're going to have soot. Okay, if there's a red reset button on the Cad Cell Relay and it's up, and the oil burner is shut down, we want to allow the homeowner to try once to reset the system. Now, some of the CAD cells let them reset it by more than 3 times, up to 3 times. Okay? One of the first questions I'm going to ask the homeowner, usually as I'm adjusting their thermostat, is how many times have you hit the safety? How many times have you tried to reset the safety? Okay? Am I going to believe that homeowner?
Never.
No, I'm not going to believe the homeowner, ever. Okay? Even if the homeowner is my closest buddy or my grandma, I'm not believing the homeowner. Okay? Because I can guarantee they've reset it more than once. Okay, if the oil burner does not turn on and runs normally and continuously for at least 5 to 10 minutes after resetting the safety, do not keep resetting the system. Okay? Because doing so can flood the combustion chamber with unburned heating fuel. It becomes a very dangerous condition. When an oil burner's firing, if you put an ohm meter, okay, on the CAD cell reading, you'll read between 500 to 600 ohms. If the burner's not firing, should be close to infinity. We've already gone over that. An oil burner that is adjusted with excessive combustion air can sometimes produce a flame that is abnormally bright, and it can give you extremely low CAD cell readings. I don't worry too much about that side of it. Okay, modern oil burners with short combustion chambers, produce a short flame. When the flame is burning well, it sometimes is harder for the CAD cell to see the fire. So again, it has to be positioned properly, no soot. Okay, they're pretty sensitive. Okay, an oil burner that uses a nozzle that produces a very narrow flame. In other words, remember our nozzle, we talked about this briefly, we're going to talk about this more. Okay, I might have a 90-degree nozzle. Okay, that's a pretty wide flame. I might have a 45-degree nozzle. Okay, that's a narrower flame. Okay, again, it can sometimes have problems, seeing that flame. Some oil service technicians try to polish up the internal components in the burner tube. I've even seen, I actually saw this, somebody else pointed it out to me once, but I saw someone spray an aluminum paint onto the surfaces inside the burner tube itself, painted the entire inside of the burner tube aluminum. Okay, those repairs are pretty short-lived. That's not the right way to do it. If they had expected the thing to need aluminum paint, do you think they would have put that in there from the factory?
If it was necessary, yes.
Yeah. So why should I add, or why do I even want to add aluminum paint in the field? Why would I need to do that?
Yeah, you wouldn't.
I really shouldn't, because I'm trying to become the mechanical engineer and second guess what was done in the development and design of this system. Okay, you never want to become the mechanical engineer. That's why people get sued. Don't do it. Okay, an oil burner whose squirrel cage fan is dirt clogged will not get enough combustion air. Remember, there's that little squirrel cage fan in the oil burner. The result for a while is that the Cad Cell is going to see a narrow flame pattern, but if I don't have enough air, the flame is going to become very sooty, and it's eventually going to soot up that Cad Cell eye. Okay, not enough air is a cause for soot, guys. I want you to remember that. Not enough air will cause soot. Okay, all soot is unburnt fuel. Okay, gotta have enough air to burn all the fuel in the system. Not enough soot is unburnt fuel. Okay, let's take a look at a couple schematics. Let me blow this up in size. These are in your course, by the way. This is called a primary control schematic. I think it's on today's material. Okay. A basically is the thermostat is just calling for heat. Okay? The thermostat is connected over here to TT. Okay? It's basically just calling for heat. Okay? So we have all of our different things in here. The safety switch heater is what I wanted to show you right here. Okay? We have a safety switch and a heater. There's a triac in here. Can anybody tell me what a triac is? Anybody in here had anything with electronics? Can you tell me what a triac is?
I don't think I've ever heard the term.
Okay, a triac is basically a switch. It allows voltage to pass in one direction or the other. Okay, so it allows you to have basically a switch that goes in both directions. Okay, depending on where the voltage is and where it isn't. Okay, so here we have the safety switch is closed. That's SS. Okay, we have a coil in here. It's the 1K coil. Now, you see why things become so important with labeling? Okay, I have a 1K coil that I just circled. Let me get rid of some of the other circles here. Where's my 1K contactors?
Right after the safety switch heater.
There's one right there after the safety switch heater. Do I have any more 1K contactors in here?
Yeah, you got another one on the 24-volt side. Immediately after the transformer.
Well, let me ask you a question. Is the left or the right of this 24 volt?
Ooh.
The left would be 24-volt. Line voltage is on the right.
Yep.
Yeah. Okay, you pointed at the right contact. Okay, but you're definitely this over here is all on the line voltage. Okay,
yes.
this is where my line voltage is coming in. Okay, so I have a 1K contactor here going to my burner motor. I have a 1K contactor that's coming off a center tap of a transformer. Okay, now my thermostat calls for heat. It energizes the 1K contactor. It closes my 1K1 and it closes my 1K2. So my burner motor comes on.
I got a question.
Yeah.
have a so in this process, that's when the transistor heats up and becomes the load, right?
This is where my safety switch heater is going to start heating up.
Right.
I think that's what you're asking, because my power is flowing from here through my safety switch, through my triac, and back to my transformer.
Okay.
So as long as my 1K, 1 and this triac is here. Now, we also have a line going to my Cad cell, right? Okay. Cad cell right now, because it's in the dark before the flame starts, has a very high resistance. I have very little current flow. Okay, so it all depends on the resistance and the current flow coming into this triac, whether or not my safety switch heater is still in the circuit, or if the circuit is completed by bypassing the safety switch heater. Okay, so now we go down to B. Okay, we are calling. See all those contactors that those contacts that are closed? Okay, these are the ones that I just closed on the other diagram. See the path for current. We're going through the safety switch heater. Okay, all this is a piece of bimetal. As the voltage goes through here, it continues to heat up, and believe it or not, all it does is heat up enough and it pops the control out. It pops that little red button out, and it shuts everything down. Okay, we go down to the third one. Okay, this is now, everything is seeing flame. Everything is good. We're coming out of our T terminal. Our voltage is going through here. Our current is going this way. Okay, and it is going this way. Okay, is my safety switch still in the circuit? Does anybody see the safety switch in the circuit at this point? Safety switch heater?
No, sir.
No, the Cad cell's bypassing it. All of this center point in here, okay, all of this in here is now being bypassed because the Cad cell is bypassing the power around this whole center point. Okay, I still have my burner running. I still have my center tap of my transformer available, but everything is now bypassing this entire center point because the resistance is so high of the Cad cell. Now, if the Cad cell stops seeing light, okay, we stop the Cad cell seeing light. It's no longer seeing light. The power is going to now come through this way. And that heater is going to start heating up again. Now, can I fix any of these? Can I fix any of these internal components in this device?
No.
The only components you can fix in a Cad Cell Relay is anything on this side. Can't fix a thermostat. You're going to replace it. Can't fix a Cad cell. You're going to replace it if it goes bad. The only thing you can fix in a Cad cell is on that side. Okay? And again, you're basically not going to fix them. You're going to replace them. But anything inside this control, you do not touch. You can pop the covers off and you can take a look at it, but you don't touch. You don't do anything with those inside. Questions on Cad cells? Anything?
No, sir.
So if I ask you what a CAD cell is, what are you going to tell me?
It's a safety switch.
It's a safety switch and
A primary control.
an operating control, right? What are my good values of resistance for a CAD cell? What do I want to see?
Under 1,000 ohms.
When it's seeing light or when it's in the dark?
When it's seeing light.
Okay, what about in the dark? What do I want to see?
About 100,000
Ohms in
ohms.
the blue.
Close to 100,000, or what might your meter show?
That's what I meant.
OL.
OL. Okay. Now, let me erase what I drew on here because there's something important I want to talk about on a troubleshooting perspective. Okay, for all things considered, okay, this entire box is what I consider a black box, okay? You have 4 terminals coming into it. You have 4 terminals for low voltage connections, and you have however many terminals. Sometimes they break apart the igniter, the burner motor, and an oil valve. We'll talk more about that when we talk sequencing. Okay, but you basically have 4 terminals that are available for you to play with to test these things out. Okay, what if the thermostat is not calling for heat? Okay, if a thermostat is not calling for heat and I have my meter leads there and there, what should I see on my meter voltage-wise?
OL?
0.
The thermostat is not calling for heat. In other words, it's open. What should I see? Think it through. What's the voltage across an open switch?
120.
20.
Will it be
Yeah,
24
but this is
in
not a
case?
120 volt source. So what should I see?
24.
24. That is correct. Across T and T, if my thermostat is not calling for heat, I should see TT. What happens if I get 0 here and I know I have power on 120 on my line and neutral? What's the problem? If I get 0 volts at TT and I have power on line and neutral coming into the control, what's the problem?
Could be the Cad cell.
I have a bad transformer. Are you going to fix the transformer in the control, or are you going to replace the control?
Replace.
Replace.
Replace it.
You're just going to replace it. This is a weird transformer. It's not like your other transformers. Okay, believe it or not, it's a 48 volt transformer with a center tap. Okay, so you're not going to pull a primary control apart and replace individual components. So again, with the thermostat not calling for heat, and I have power to control across T and T, I should get 24 volts. Okay. Across FF, with no power on this unit, okay, and one of my leads has to be disconnected, so you're taking it from the lead to the CAD cell. What should my resistance be? No power. What was that?
With it off?
Yeah, I have no power to the unit because I can't take resistance on anything powered, and I have one lead disconnected, and my meter is actually on the lead, not on the terminal?
Around 100,000.
Yep, around 100,000. Okay, I turn this sucker back on, I close my thermostat, in other words, it's calling for heat. I have one lead off the Cad cell. What should I get on my Cad cell? Again, I have one lead disconnected. The meter lead is on the wire that's disconnected and on the other F terminal. What should I get on the Cad cell? By the way, this is a trick question.
Oh. Still 100,000?
Why?
Because you have one lead off.
What will the primary control do if I don't have the Cad cell connected?
It will work, right?
It'll trip your safety switch.
It will work for whatever my trial ignition time is. So what is if my ignition happens and if I have flame, what will my Cad cell show in that brief 30-second to 90-second period?
Under 1,000.
Yeah. Now, if I want to do more testing and I'm sitting there, I know I have flame, can I put a jumper from here to here?
Yes.
Do I have to do that while... You're right on yes, by the way. Do I have to do that while the system's running, or can I do that before the system starts?
Before it starts.
You were right on the last one, but we have a problem on this one. One of the features of the Cad Cell safety... Now, one of the features on the Cad Cell is I cannot jump FF before the system starts. I can only jump FF once flame is established. That's to prevent a homeowner or a service technician from leaving FF jumped and just letting the system run. Okay? The minute we take power off of here, the minute I open a service switch or anything or the flame shuts off, if FF is jumped, I can no longer start the system. I have to take one of the leads of the jumper off, let the system start, let it go through, and then I can put the lead back on. But I cannot have FF jumped out when the Cad cell is starting up. It won't allow it. Okay? Now, if you are taking all these meter readings, and if you have to put a jumper on while you're taking these meter readings, where's your third hand going to come from? I mean, in all seriousness, you have the Cad cell here. You're holding a meter on it to see what your Cad cell's doing. What are you going to do? How are you going to get that jumper on?
I mean, can't you clamp your meter?
Yeah, that's why in your meter bag, when you first got your meter, those two little clamps in there, okay, that fit on the end of your meter leads. They either push on or screw on. I forget the types you have. That's what those little clamps are for. So you can keep your meter in a circuit while you're doing something else. Okay? Don't lose those two little clamps. By the way, you can buy replacements of those on Amazon real cheap. I know this from experience. I leave them places. I don't know why. They fall off and I leave them places. Okay, the other thing you can do, and we'll talk more about this when we're bleeding in oil, when we start talking about bleeding in oil system, your little 3/8 inch open-ended wrench, your little 3/8 inch wrench is perfect size to fit and hold down on that FF terminal if you need to. The little 3/8 inch open-ended wrench is perfect size to hold down on that FF terminal, and the voltage is so low in here, you don't have to worry about it. But we do that a lot when we're bleeding oil equipment out because you've got to keep it running and there's no flame. Okay, so again, it's getting that jumper on there and keeping that jumper on there while the system is running. Okay, in order to make sure that you can still continue the flame process while you're doing your testing. You cannot have FF jumped when the system is starting. Cannot do it. And it will only last for the one call for heat. The minute this burner turns off, you've got to remove that jumper or it will never run again. Now, having said that, what is a frequent callback for oil techs who go out and service oil equipment and the burner's running as they're leaving?
Or leave it at FF connected.
They've left their jumper on.
Yep.
Homeowner will be all nice, warm, and toasty, think everything is fixed. About an hour and a half later, they're going to start getting cold because that system will not restart. And someplace, somewhere out there, a technician is going to get a call on that one. If you're lucky, you used alligator clips and your customer has a sense of humor and you can say, oh, crap, I forgot to remove my alligator clips. Are you on a phone where you can go down and take a look at it? There's probably a set of clips that's red there, it's hanging there. And can you just pull those off for me and everything should start working? And you'll apologize profusely and move on. Okay, that's why I always have alligator clips as well, because I never bypass a safety while I'm working on a piece of equipment without alligator clips. Because if I have alligator clips on something where I've bypassed a safety, I could tell the homeowner, just yank the wire off, yank the alligator clips off, everything will start working again. Because even the best technicians, you'll eventually get in a rush, and you'll leave that safety bypassed. Any questions for me on anything we've covered today?
Can't say I do.
Anybody else? Okay, folks, that's all I have for today. This recording, I'm going to hold off a little bit on posting it. It will be posted a little bit later in the afternoon.